Hi, welcome to watch this video. So these are all the materials you need. Now we begin the first step. We shall install the rotor on the UAV arm. Here you may find two bags of bolts, one for the frame and one for the rotor, so please don't mix them up. So after you install the rotor, and the final product will be like this, and this is only the first step. We need the ESC, electronic speed controller, to control the speed of rotor. So this is ESC, and the electronic wire and signal wire behind it. Be aware of the connection between the rotor and the ESC. I'll talk about it later. Here's a PX4 document of user guide. What I want to show you is a airframe of quadrotor X. Each circle represents a rotor, and each rotor has one index on it, like 1, 2, 3, 4. As you can see, for each rotor, they have the arrows to indicate the direction of rotation on it. Like 1, 2 is counterclockwise, and 3, 4 is clockwise. And of course, the rotors can be divided into counterclockwise or clockwise. Make sure you put the right rotor into the right position, because if you don't, here comes a problem. It actually took me some time to figure out what is the problem, and clearly I put the rotors into wrong positions, so don't make the same mistake. So if you are using the exactly same component as mine, I strongly advise you to connect it in the same way as I did. So my ESC is Hobbywing X rotor brushless ESC with 20A. If you're using other brand, install it in the way you like and test it, adjust it later. Next, we're gonna soldering it on the chassis. Remember, we have the electronic wire and the signal wire right there. By connecting to the battery, the board will provide the power to the rotor and, of course, ESC. Connect the red wire to the anode and the black wire to the cathode node. If you don't know how to do the soldering, learn it first, please. First, put the tape to fix the wire. It helps the soldering. Because the wire is thick, so I strongly suggest we put some tin on it first. And put something on the copper plate. And make sure they could strongly connect with each other. Then melt the tin to connect them and put more on it. So this is our final product. Not good looking, but it works. Now we gotta connect the battery to it. It should be plugged in here. So this is the battery. As you see, we plug the male head into the female head on the converter. It transfers the current into the rated voltage so that the UAV could use it. The problem is we don't have the socket on the chassis board, so we may have to chop the male head off and soldering the wire to the copper plate. Yeah, it looks very bad, but yeah, it works, maybe, okay? Same principle, the wire is thick, so we put the tin on the wire first, and the both sides. Use the tape to fix the wire. Put the tin on the copper plate, and make a solid connection. The last step, use a multimeter to test the circuit. If it has any connection problem, you may have to desoldering it and fix it. If the circuit has no problem, use a glue gun to seal every soldering joint you made. It helps protecting the circuit. Next, remember 2 bags of bolts. We're gonna use it to assemble the frame. After putting everything together, it becomes a complete frame without wiring. But as you may see, you have to attach the component to the frame. We use the cable tie to tie the ESC on the UAV arm, and it looks like this. Next, the deployment design is also important. What I design is to put the battery and flight controller in the central place. How I place the battery is to create the battery cabin inside of a chassis. I use the Velcro cable tie to create an entry for the battery. Anyway, you can design your own deployment. Additionally, your converter can not only provide the electricity to the chassis board, but also the flight controller. Pay attention to the socket here. You can connect your flight controller to this socket through the GST-GH wire. So this figure shows how we make the connections. It makes sure the power could be provided to the flight controller. However, we still need to mount the flight controller on the plate. But we are not directly stick that on a plate. Instead, we use a vibration damping foam. Stick it between the plate and the flight controller to isolate the vibration. After all of the mounting and wiring, your drone should look like this. But this part is wrong. Remember we talked about the index number? Each index number means exact pin node number on the flight controller, which means you have to plug the rotor 1 to pin number 1 and 2 to 2. Meanwhile, you have to make sure your flight controller is facing the right direction relative to your rotors, as this is the right way to connect them. Additionally, R9DS is a receiver. It receives a signal from the remote controller. Establish a channel between flight controller and remote controller, just to plug it in RC-in socket. Next, we proceed to the firmware writing. Connect your UAV to the computer and follow the steps inside the self-learning material. I think it is quite clear. At last, we proceed to the trial flight. Please remember, when you're debugging your UAV, don't install the propeller. Do select the safe place, for example FJ005, to prepare your trial flight. Before you're taking off, arm your UAV first. You can do it on computer. Your computer is ground control. But when you're using the remote controller, put the throttle at the lowest and push it to the right. Then your UAV is fully armed. When you're debugging at this stage, you can check the direction of each rotor. Then start your trial flight. Be careful.